And then from there it would go into separation, and then from there out. So it would be separated into gas and liquids, and the liquids would be exported. This is the main support frame. This is just the form of the platform. This is the jacket that goes down onto the sea floor. Flare boom, obviously if you're producing gas while you producing the oil's coming out, then the gas has to go somewhere. Now these days, flaring gas is not very popular. In fact, there are usually all kinds of environmental legislations against the flaring of gas, and the production of oil is very often limited by the amount of gas that can be flared. But of course, best of all would be if the gas can be collected, if there's enough gas that makes it worthwhile actually collecting it and sending it onto shore. But what also, there's water injection here. Water injection is used to actually keep the pressure in the reservoir up. So think of this rock formation under the ground, this solid sponge that you're pumping water in under high pressure, which is then lifting the crude out. But also what they're doing more and more these days is gas injection, where they're injecting gas back in, and this gas is lifting it up, which of course is a more efficient use of the gas rather than flaring it. Gas compression would be used either for the gas reinjection or else if they're exporting gas. So that's just a slide that once again you can look at sort of at your leisure and get an idea of the components that you actually have on a platform. Pipelines and flow lines. Won't go into too much detail on this, but the question that I very often get is, what's the difference between a pipeline and a flow line? Flow line basically is the line between the well and the platform, and that's normally called the flow line. After the gas and the crude have been separated and cleaned up and processed and are put into a pipeline for sending onto the shore, then that's a pipeline. That has its own risks associated with it. Paul sort of talked a little bit about the laying of the pipe, and of course he sort of talked about the joint and the X-ray and the UT inspection of the joint, and then the covering with the mastic, and they usually put sort of a metal sheath over that. But of course, one of the big risks with pipe lay is pipe buckling. And this is a big problem, and of course, a large number of our claims have been pipeline buckle orientated. So as pipeline flow lines. Flow lines, usually the problem there is corrosion, and because what you've got well fluids, so you've got gas, liquids, water, sulfur, etc. So it's a highly corrosive mixture coming out of your well, going through your flow line into your platform. So that's the kind of risk that you've got there. Just riser, and of course riser is where the line goes from the seabed into the platform, actually going up. And the significance of that, and we'll go into that in a bit more detail in this afternoon's presentation, that the riser, because it's usually exposed, and because it's under fairly high pressure with hydrocarbons, that's a risk as far as collision is concerned. And we talk about the Bombay High incident this afternoon, where a supply vessel actually hit a riser. There's a leak, rupture, leak, fire. Platform was wiped out in 2 hours. So just sort of think of this flow line from the well into the platform, a pipeline from the platform to the shore, and the riser from the seabed into the platform. Just a shot of a subsea pipeline, a shot of an overland pipeline. This looks a lot like Paul's slide. We probably shared it somewhere along the line. This is the subsea development. All those Christmas trees are down on the sea floor. And what sort of tends to happen is that there's sort of a continental shelf that goes out so many miles, which has a depth up to about 120 meters. And then after that, it drops down quite low. And most of the subsea stuff that we've been doing is in the region of 1,000, 1,200 meters deep. So, in fact, it's a kilometer under the sea. So, obviously, divers can't do that. All that is done remotely using ROVs. And you saw an ROV vessel a little bit earlier in the earlier presentation. What is a triple SV? What's a workover? What's a ESP? What's a beam pump? The important thing there is a triple SV. The triple SV is the subsurface safety valve, which is installed about 100 feet below the surface. And this is your first line of defense. If there's a problem, you can close off your triple SVs. A workover is when there's an and I mention this because workovers have a certain rate against them, and insurers in this business are usually concerned about workovers. Who does them, how they're controlled, is there BOP in place, all this sort of thing. So all you need to remember about workovers, it's a well intervention. It's something which is carried out on the well after it's been drilled and after it's operating. And it's usually to sort of do maintenance on that particular well. And then ESP, beam pump, just sort of very quickly on this. That's the ESP. Somebody asked me in one of the presentations what an ESP was. It's the electrical submersible pump, and used a lot in Sudan, especially with the sort of heavier oils, where the oils have to be pumped out, and usually when the field is depleting and there's not much natural pressure. That's a beam pump, the old nodding donkey, so-called nodding donkey. Not many of these around. Funnily enough, the only place that I've seen them is in the UK. We had a client there who actually had quite a few of these nodding donkeys, and I did a survey on their facilities, and I've never seen them anywhere else, which are... didn't see them in Alberta, no, it didn't. No, but, yeah, I found that a little bit strange. Mentioned earlier LPG, LNG, and FLNG. LPG is a mixture of C3 and C4, propane and butane, 50-50 mixture. It's the gas which you use for your barbecue at home. It's the gas that you use for heating your hot water. Under a fairly low pressure, it can be liquefied. It doesn't have to be kept very cold or anything, and it's a fairly useful source of energy. The problem is if you have a leak, it's one of the worst possible leaks that you can have, because it just sort of sits there. It doesn't dissipate, it just sits there. And of course, with refineries and offshore platforms, one of the first things that underwriters ask us, is there a chance of a vapor cloud explosion? And there is if there's LPG. Whereas LNG, these are just showing LPG spheres, under pressure, not a very high pressure, probably 4 or 5 bar, and it just keeps it liquid. Whereas LNG is methane, which is then liquefied. And Paul asked about the temperature. I should have had it at my fingertips, but I think it's about minus 170 degrees C. In that vicinity, keeping in mind that minus 273 is absolute zero, so it's sort of about halfway down there. And this is like a large thermos flask. It's actually constructed a bit like that. You have an air gap in between, and made out of concrete, and on the outside and with a stainless steel inside rim. And then the liquefied methane is kept in there. And that's just a shot of the sort of the kind of storage facility. Floating LNG, we have a client. We have a client in Malaysia who's now moving quite strongly into floating LNG. They've got a second project going. Jeff, 1.6 billion a throw, is it? About.
Well, we're actually, if you add the additional coverages on there, we're going to 2.5 billion.
Okay.
So the value, plus you have your removal of wreck, and you have your sewer labor type additional coverages, which we'll talk a little bit more kind of this afternoon with operational insurance. So it's pretty much capped at about 2 billion.
Yeah. So big projects, exciting projects. I mean, what's basically happening is that they used to have LNG plants on shore. So they used to produce the gas, ship it onto shore, where it got cleaned up, was then liquefied, stored, and then taken off from there. Here you've got a situation where the whole process is happening offshore. So it's like a tanker on board which you have the receiving, the cleanup, the processing, the liquefaction, and the storage. And as you can imagine, all sorts of very interesting risks come out of this. You've got the role of the ship itself. So in your columns where the actual where the level of the liquid on the trays is important, this has to be compensated for. Your storage tanks, you can't have your storage tanks half full because you have a sloshing effect where the effect of the LNG actually hits against the insulation and causes damage. The slightest leak, of course, you've got this very, very cold liquid, which, and of course, freezing steel very, very quickly makes it brittle, so you have to use special metallurgy there. So from a technical point of view, this has been a fascinating project, but at the same time, insurers have been a bit concerned about it, and they've been paying a lot of attention to it.
It's very prototypical. I mean, Shell are building one right now. It's actually started before the Petronas one, but it's a lot bigger. It's the length of 6 football fields, and it's worth about $7 billion. But you can't buy, there's not enough capacity to do that, so they basically insure, some of the insurers insure up to about 3 billion, some up to maybe 2 billion. So they're running really net on it, because there just isn't enough. It's very prototypical. So watch this space really as far as, but there's going to be a lot more of these being built now. This is the new way forward.
Yeah. And if you do have a client who has that, please come and see us, because we've got the best rates in the world for this particular floating LNG. So yeah, it's okay. A rig, a semi-sub, jack-up. Paul touched on all of these, but I'll just skim very quickly through and sort of separate them out a little bit in your mind. A rig is used for drilling wells. Some people use rig and platform fairly interchangeably, but in fact, not so. A rig is used for drilling, and that can be either a jack-up, where it's firmly in position, or a semi-sub, where it's held in place with DP. And a jack-up, and the guideline for that, I won't go into this in detail because Paul handled that quite a lot, is roughly 70 meters. What we find is that 70 meters or less, we usually assume a jack-up in all our calculations, and that's what our client normally does. There are some quite fancy jack-ups these days that can go down to 120 meters. Yet then the jack-up starts to become so expensive that you might as well use a semi-submersible. So 70 meters is quite a good cut-off point. And then deep water, usually more than 1,000 meters tends to be deep water. Shot of a jack-up, you saw lots of jack-ups earlier, so I won't dwell on this one. Just another jack-up. Here's a semi-sub, which doesn't have to go all the way down. Those Meccano legs don't have to go all the way down to the sea bottom. Just another semi-sub, drill ship. And you saw enough of those, but I'm just sort of recapping now as to drilling barge, used in Nigeria a lot, sort of in the lagoon area and that area where shallow water and they can just drill directly off a barge. Land drilling rig, again, lots in Sudan, lots in Iraq. Yeah. This is important. This is important from an insurance point of view. Are the different wells and the different definitions of these wells. The sort of thing that you can go back to afterwards, because I think absorbing all of this now might be a bit much. Yet an exploration well is drilled when there's a promising geological formation, and you go down to find out if there is if there are hydrocarbons there or not. An appraisal well is then drilled to see how much is there, how quickly it can be recovered, how many wells you have to drill, in other words, the economics of the whole development. Development well is then drilled, and very often your appraisal well can be converted into development well, which is then drilled with the idea of that being completed. Now, I'll explain these expressions just now, and you complete that and it becomes a production well. So your production well is the well which is actually producing your hydrocarbons. Shut-in well, I mention this because it's a class of, as far as the insurances are concerned, less risk associated with it. Some operators don't even insure their shut-in wells, but at the same time, it's quite a good idea if you do because of leaks that can develop. Well plugged and abandoned, it's after being shut in, the next step is plugging and abandoning it, which is pumping concrete in, which is actually shutting it off completely. And then injection wells, sometimes you have sort of 4 or 5 production wells and 2 injection wells. And I explained earlier, you can either inject water or gas to keep the pressure up in the reservoir under the ground. This, I think, is quite useful. It shows you one drills down like this, and while you go down, you put in casing at each level, and then you squeeze in cement in between the drill face and the casing, and the casing, you can think about it almost like a telescope, which is being unwound. Eventually, after you've drilled and you've reached the level that you want to, and this is the area where the hydrocarbons are, you then put down your completion tubing, and you put in a packer, and then you detonate the perforation. So you actually shoot bullets through the side of the casing, so that the hydrocarbons can flow in through these holes. They can't go through the packer because that's in place to stop it, and it forces the hydrocarbons up through your completion tubing. So that explains the drilling of a well, the casing, and we talk about that a little bit this afternoon as well, because this is quite important that this is done, and the completion, the perforation, the packer, and the production. It's the kind of thing that perhaps you might want to go back and look at a little bit later, but that's quite a good scheme to actually show what happens. Right, spudding of a well, just very quickly on this, mud, drill bit, etc. The spudding of a well, important from an insurance point of view. Insurers want to know when the well's spudded. And that's when the drill bit actually cuts through the earth for the first time. The drill bit, we show a drill bit just now. The mud, it was called mud because in the very early days they used to use water for the drilling, and the water and the rock and the dust used to form a mud. But in fact, these days, it's a very complex chemical mixture, usually diesel-based with various chemical additives. And this is used for sort of taking out the cuttings while the drilling is actually happening, and at the same time cools down the bit. So it actually supplies two functions. Mud density is important, and again, insurers are concerned about this. They're very concerned about underbalanced drilling, and this is now used more and more when a field is depleted to try and get the best out of the field. But of course, you now have a situation that your primary control when drilling, and Jeff, I guess, will be going into this in a lot more detail, is a column of mud, which is then keeps the hydrocarbon pressure in place. A drill bit, quick shot of a drill bit. Casing, showed casing, cementing, completion. Won't go through that again. Sort of thing you can look at. I explained very, very briefly what it was. So your cementing is between your casing and your hull. What were the other things? Cement, packer, etc. No, it's all here. Blowout preventer, absolutely key. When drilling, you actually drill through a device called a blowout preventer, which is your last defense stage. So if there's a blowout, your BOP kicks in, and these rams then close. These rams close. They cut the drill pipe itself, and they shut off the sort of emergence of the hydrocarbons. Talk about Macondo this afternoon, and the malfunction of the BOP on the BP Gulf of Mexico Macondo thing was largely as a result of this not working. You know, had that worked, lots of the other things wouldn't have gone wrong, although that wasn't the basic cause. FSO, FBS. I won't worry about the first two because I think Paul handled those in quite a lot of detail this morning. The floating production and then the floating storage and offloading, where there's no production on there. But what I do want to show you is a floating production system, FPSO, shuttle tanker, a single point mooring. This I do want to show you. I was on board that doing a survey 2 weeks ago, also $2 billion worth of hardware. In water depth of 1,200 meters. It's a Shell-operated facility down in Malaysia, and producing 135,000 barrels a day of oil, which is a very good production, something like 25,000 out of one well. So it's almost a Macondo-type situation offshore Malaysia, and a very slick operation, a very good survey all around, and quite an exciting project.
To give you an idea, that platform is 42,000 tons. This is the platform. I mean, that's a very, very heavy piece of kit.
Yeah. So what